In this video, we're going to construct a confidence interval for a population mean. The context here is kind of silly. It's about unicorns. And we have a scientist who's been studying unicorns, and we have data on the length of unicorn horns reported below. So we have the length of unicorn horns for 9 different unicorns, and the units are inches. And we want to use these 9 unicorn horns to estimate the mean length of all unicorn horns at a 95% confidence level. So in terms of stating what we're about to do, we are interested in the mean length of all unicorn horns, and we will construct a 95% confidence interval. So we write that out. Next, in terms of making a plan, we want to make sure that the situation or the environment or the data meets the criteria to be able to do what we want to do. We have to make sure that if we plan to carry out a T-interval, that we actually are able to do that. So it's the same criteria we've been working with. We want our observations to be independent. To check if our observations are independent, we want to check that the sample was randomly gathered, so we have random observations from a large population. That would make our observations independent. So we go back up and we just kind of confirm that yes, it was stated that it's based on a random sample of unicorns. And then we have to make an assumption here that we want to be sampling from a large population, and our 9 unicorns that we've observed, we need to be able to assume that that is sampled from a large population. And our definition of large is at least 10 times bigger than this. So we have to be able to assume that there's at least 90 unicorns in existence. So for now, we're going to make that assumption and then move on. We also want to know if our sample size was large enough. It'd be nice to have 30 observations in our sample size. Right now, our sample size is 9. And so because of that, though, it doesn't mean we have to stop. It means that because our sample is small, we really need to have a very symmetric, or even better, a normally distributed population. But since we have this histogram right here, our sample is quite symmetric, so it's reasonable to assume that our population is also symmetric. So a sample size of 9 is good enough because as the sample size increases, the sample mean becomes more and more normally distributed. So a sample size of 9 here is going to be sufficient. Okay, now we actually carry out the procedure. We need to find these ingredients. In general, a confidence interval is as simple as taking your best guess for the parameter. We are trying to estimate the mean length of all unicorn horns. So our best guess for the mean of all is the mean we observed in our sample, which happens to be 11. So our statistic is our sample mean of 11. Our sample mean has some variability built into it. If we took another sample of unicorns, we might not get 11 again. It'll naturally deviate from the true center. So our typical deviation we can estimate based on the standard deviation from our sample, 1.49. So our formula is going to be the standard error of the sample mean is the standard deviation over square root of n, the standard deviation from my sample. So this is going to be 1.49 over square root of 9. And this is 0.497. So our unicorn horn lengths, right now we assume on average they're about 11 inches, and they typically might deviate from this 11. The sample mean would typically deviate by about 0.5 inches. If I gather another 9 unicorns, it's expected to be within about 0.5 inches of whatever the true center is. Okay, our critical value is going to come from the question of how many standard deviations or how many standard errors are going to represent the middle 95%. We can draw this picture that has the t-distribution drawn, which looks a lot like a bell curve, and I labeled it degree of freedom 8. Remember, your degree of freedom is your sample size and then 1 less. So if we've measured 9 unicorns, our degree of freedom is 8. And if we want the middle 95% of this theoretical distribution, and we want to know how many standard deviations or standard errors would capture the middle 95%. So we use the inverse distribution, the inverse t-distribution to answer that. But the problem is the inverse t-distribution doesn't care about the middle 95%. The inverse, sort of by definition, is up to and including. It's a left thing. So to the left of my upper critical value here, I have to sweep through the 95% plus the tail. So even though it's a 95% confidence interval, I'm going to use 0.975 for my area, and my degree of freedom is 8. So 2.306 standard deviations is my critical value, which intuition says 95% should be about 2 standard deviations. So this seems very reasonable. So the margin of error is as simple as putting together 2.306 standard errors, 0.497. We get about 1.15 inches. So this means, putting this all together, our confidence interval is the statistic, so 11 plus or minus our margin of error, 1.15. And we can write it as an interval. If you subtract 1.15, you get 9.85. If you take 11 and you add 1.15, you get 12.15. So now that is our do stage. We did all the calculations and all the thinking. And to conclude, we just write a statement putting it all together. We can be 95% confident that the mean length of all unicorn horns is between 9.85 and 12.15 inches. And that concludes the process and the full confidence interval.